In Azure SQL Database, learn about all the new ways that you can use to automate things like scaling up and down, like T-SQL, Logic Apps, and Elastic Jobs. This week on Data Exposed, SQL Insider Edition. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed, our SQL Insiders series. Today, I have with us a very special guest, Stephen, who is a cloud solution architect and a SQL Insider. Stephen, thanks so much for joining us today. Can you kick us off by telling us a little bit about what you do?
Sure. Thanks, Anna. As a cloud solution architect, what I do is really help our customers understand how the data services work and how to use them to solve their problems.
Okay, cool. Sounds great, and sounds like a great thing to have on our show. And today we're going to be talking about Azure SQL Database. Specifically, you wanted to talk about how you can automate scaling up and scaling down. So before we get into it, I wanted to ask, why did you want to cover this topic, and what is this topic really about?
Yeah, thanks for that. So I get a lot of conversations with my customers. One of the great things about SQL database and all the PaaS services is the ability to both scale up and scale down so that you use the right amount of resources for the job you're doing. And we do this a lot with all of the areas around our Azure services. But when I talk to DBAs, it's sometimes a challenge because a lot of them are not infrastructure people. So they don't know PowerShell and they may not have access to the Azure portal. But when they're working with their SQL databases, there are times that they do want to have some scale control, particularly if they have big jobs running or they need to change the size of their max database size. They want to be able to do that. They want to be able to automate it, but they don't necessarily are going to have all of the types of controls and tools that Azure admins are going to have. So really, I want to focus this for the DBA today and do everything in Transact SQL.
Oh, okay, exciting. I think our DBAs are really going to like that. So let's get right into it. What do you got?
Sure. So just take a look at my deck here. Everybody knows that we can scale, and there's a scale both in the DTU model and in the vCore model. And really, what this means is that I can take a SQL database and I can have it small or big, and I can go back and forth. Now, what's really nice about SQL database when it scales is the way that it scales. And so the way it works, when I issue the scale command, it makes the change behind the scenes. It actually creates a brand new instance of my database. So it goes through the whole provisioning stage while my database is still in use. And then when it's ready to go, it actually just pauses the connection briefly. It repoints from the DNS from my current instance to the new instance. It detaches and reattaches the database, so there's zero data loss. And then my database comes up. So it may take, minutes or even hours to move a database, but my actual downtime is usually a minute to 2 minutes max. And I wanted to, you can control all of this with Transact SQL. And so as I'm working with my databases, if I know I have periods where I need a bigger job. So the client that sort of was the impetus for this presentation for me, they have a batch job that runs on weekends. And they've tuned their database so they've got the right size, but this job is a lot heavier than their usual workload. And it was starting to spill into the production on Monday morning. So what they wanted to do was automate the increase in the database so that it had more horsepower to run the job and then finish within the time window that it had allotted. And then they wanted to bring things back down again because they didn't want to pay for a much larger instance than they actually need for their day-to-day operations. And that's sort of what I want to show today. So why don't we just take a look at the code here. So the first thing I want to do is I want to look at just how we can scale out the size of the max database size for my database. So let's just take a look at this instance that I have here right now with the clever name of Autoscale Demo. And I can see here that It's a general purpose. It's a Gen 5 with 2 cores, and it's got about 75 gigs of space. So now what I want to do is I want to add another 50 gigabytes to this max database size so that I've got room for the work that I'm doing. So all I'm going to do here is declare some variables. I'm going to capture the size that I want using that database property X function. I'm going to add my current size with 50 gigs to make it the new max size. And then I'm going to dynamically create an alter database statement that just simply modifies the max size value. So if I take all of this and give it a run, this one actually runs quite quickly because it's so small. And if I go back and take a look again at my sizes, we've now added 50 gigs to that. So it's up in the max sizes there. Now, we haven't actually moved anything, and that's why the speed is so fast. So if you go and look at the database itself, you can see it's really only using 21 megs. It's got 32 megs allocated, but my max size is now bigger. And because we're not really moving anything, there's no interruption on the database. So as a DBA, I can go in, I can monitor my size, I can make my changes dynamically. I don't have to bring the instance down in any way. And I can do it all with Transact SQL. Now, let's take a look at actually doing this, but with changing the actual size. So to do that, what I need to do is I need to change what's called the service objective for my database. And the service objective is just the tsert size setting for what size of instance I'm running. So in this case, I know I'm running a general purpose Gen 5 with 2 cores. And what I'd like to do is I'd like to scale that up to 4 cores. So if I take a look right now, I am running 2 cores, and now I'm going to run my alter database statement. And it says successful, which sounds great. But if we take a look, yeah, that was fast. But if we take a look, it's still a Gen 2. And if I go and see what's going on, I actually have here, and it doesn't look like it's running, I've got a little loop that's just querying what the current service objective is. And what we're going to see is that it's going to run here for a minute or two, and then we're going to see a service interruption. And actually, the connection is going to be broken here. And as soon as that happens, then I'll know that my change has taken place. So right now, everything is still running. In the background, a whole new instance is being created. It's being created as a Gen 5 with 4 cores. And at some point, we'll stop the connection. There we go, right there. And so you'll see here I've lost my connection. If I go back and look at my service objective, I'm now at Gen 4. Now, this was really fast because my database is almost empty. I kind of did that for the purpose of the video. If you had a terabyte database, that cutover could take an hour or more, depending on the size you're moving to and depending on how much data you have, because it's actually going to detach the data files, move them over, and then reconcile everything together. So the only thing I really lose are any uncommitted transactions when the cutover takes place. But I've done this all within Transact SQL. Now, from the automation standpoint, there's lots of things I can do to automate this. So here's one example. I have a logic app that I've created here. And if I go into the designer, and again, very simple logic app, I set my recurrence, so I'm going to schedule when this happens. I create a simple SQL statement. I do my alter database, just like I showed you in the script. I then do my batch job or whatever it is that I needed to get done with the process, and then at the end, I just scale it back down again. And so, just using Transact SQL and with simple automation tools, um, what I can do now is I can schedule my scale up, then run what I need to do, then schedule my scale down. Now, because it takes time and because there's service interruptions, there's a couple things I have to make sure. One, my applications that I'm connecting to my Azure database, I want to make sure that I'm using retry logic in those apps. Now, that's not just because of this. That's actually best practices for working with SQL Azure, making sure that the connections are always there. The other thing is, I don't want to set this up to automatically scale up and down based on, say, performance. If I want to scale on performance, then looking at SQL Database Serverless or Elastic Pools or some other technology is probably a better bet. But if I know I have those jobs where I need to scale up, do something, and scale back down again, these are really good tools. And then the other thing that's in preview right now, but is coming up soon, is I can do Elastic Jobs. And so with these jobs, again, all with Transact SQL, I can define a job. And I know that, Anna, you've done a whole series on this, so I'm sure we can put links to those. But I can define a job, just like this one here, put in the alter database text that we saw, set the credentials, and then I can schedule that job all within the Elastic Job Scheduler. So lots of options there for DBAs. Getting back very similar to what we had with SQL Agent and with automation jobs. So we can take the full advantage of the scalability of Azure, but still be in that familiar world where the DBA feels comfortable and where you are working in the space that you know. So I just want to make sure that the community was aware of this and can really get the best advantage from SQL Database.
Awesome. Thanks so much, Stephen. Actually, I love the way that you took us through this. You showed us, hey, this is how you change your slow using simple, good old T-SQL that we all know and love. Then you said, hey, you want to take it to the next level? Check out Logic Apps, which are super easy to use. You can set up automation yourself. And then you came back and said, hey, if you really like T-SQL, there's an option for you in Azure SQL Database. Like you mentioned, we don't have SQL agent jobs in Azure SQL Database, but we do have Elastic Jobs. So I love how you kind of went full circle with this. I think it was really useful. I learned a lot. I think our viewers probably learned a lot as well. Do you have any tips or tricks for folks who are just getting started with automation in Azure SQL Database?
Yeah, so make sure that you understand the various sizes because they're all sort of preset. So the amount of cores, the amount of RAM you have. There is also some limits where the max amount of storage I can have is contingent on the number of cores I have. So it's good to go in and take a look at the scale sizes and make sure you understand them. And just remember, this is still a SQL database. You're still tracking performance. You still have that level of control you have on-prem. You're really just extending into a new and more exciting venue for working with your data services.
Awesome. Cool. Well, thanks so much for that, Stephen. Thanks to our viewers for tuning in. To our viewers, if you like this episode, go ahead, give it a like, leave us a comment, and let us know how you are using automation in Azure SQL Database. And we hope to see you next time on Data Exposed.